find the equation of the line through the points A and B, where A is 3,7 and then B is this. So these are like position vectors. So to express them in position vector form, you can either use ij components or you can write them as column matrices or column vectors rather. So that means your OA will be, this is the x, so it will be 3i, then the 7 is your y, so this will be 3j, and then your b is your vector OB will be, this is x, so it will be 2i and then minus 8j. So now to find the direction, remember the equation of the vector is given by a plus lambda b, where a is any point on the line, so you can either pick this or this, and then b is the direction of the vector. It's more or less like the gradient. So to find the direction, you can just find your AB. So your AB is given by AO plus OB, or depending on what you were taught, your AB will be, you can start with this OB and then swap this. The moment you swap this, the sign will change because you have changed the direction. So whether you use this or you use this, your answer will still be the same. So I'll use this one because this is what we normally use. So we can say the direction vector AB is given by AO. AO is just the opposite of this. So instead of getting this, we can just put a negative sign in front. 7j, then plus OB, you can just get it as it is. So your AB will be negative 3i minus 7j plus 2i minus 8j, and then like terms together, negative 3i plus positive plus 2i, this will be negative I, then negative 7j minus 8j, this will be minus 15j. So this will be the direction. So then your equation will be R is equal to A plus lambda B. So you can say R is, your A is any point on the line. So you can either use OA or OB or any other point that has been provided. So for me, I'll go with the first one. So I say 3i plus 7j, then plus lambda. Your B here is the direction vector, which is this, minus I minus 15j. You can as well write this as 3i plus 7j, factor the minus out, plus 15j, and you're done. So in case you are not sure and then you want to verify whether your answer is correct or not, you can simply substitute this one here and then check if you will be able to find a lambda which will satisfy the equation. So before we look at the second part, I'll go ahead and verify this for you. If you're okay with that part, you can skip it and go to part B. So if I use this, it will be too easy, so I'll use the other point. 2i minus 8j is 3i plus 7j. You can expand this. By the way, this is the answer. This is just the proof, and then minus, this will be lambda I, this one will be 15 lambda j. Of course, this will be a minus, and then you can equate the I components with the I components, and then the j components with the j components. So I've just gotten this one and this one. I'll factor the I out, this minus this, and then you can factor the I out, and then I can get this one together with this. So I have 7 minus 15 lambda. Let me factor the j out like this. So now when you equate the I components with the I components, you have this. And then you equate the j components. So the coefficient of j here is minus 8. The coefficient of j here is 7 minus 15 lambda. And then your lambda here, when you take your lambda, you have lambda is 3 minus 2, which means lambda is 1. Then you can bring this one to the other side. You have 15 lambda is equal to 7 plus, when you take this one to the other side, you have a 15. When you divide both sides, you can see that the lambda is equal to 1, just like before. So this tells you that this point indeed is on the line with this equation. So you don't need to prove your answers, but in case you are doubting your work, you can always do this just to be sure. So now let's look at the second part. So the second part is saying find the value of t for which p, which is 2i plus 3j, and q, which is 2 squared I minus 9j, are perpendicular. So when two vectors are perpendicular, it means their dot product is a 0. And the answer, and the reason is very easy, because the dot product is given by this, the dot product of a and b. So you have a vector a multiplied by the vector b is given by the modulus of a, that is the magnitude of a, multiplied by the magnitude of b multiplied by cos theta, rather, not 90. Yes. So now when two vectors are perpendicular to each other, it means the angle between them, let's say one vector is like this, the other one is like this, it means this angle here is 90 degrees. So where you have theta, you can just put your 90 degrees. And once you put your 90 degrees, you know from your calculator, if you haven't memorized it, that cos 90 is 0, as you can see. So this is why we say the dot product of two vectors which are perpendicular to each other is a 0, because when you put your 90 there, you have a 0, and then everything multiplied by 0 is 0. So in other words, when I multiply this by this, I should get a 0. So let's do that. Ti plus 3j dot, then t squared I minus 9j is a 0. If you want, you can even show all this, but it's not necessary. You can just state it. So now when you are multiplying two vectors, just multiply the i's with the i's, the j's with the j's, because when you multiply I by j, you get a 0. Remember, I is perpendicular to j, so once you multiply these two, this thing will happen again, so you don't have to multiply these. So you can say this multiplied by this is t the power 3. Then 3 multiplied by minus 9, this will be minus 27. Everything is equal to 0. Then we have t cubed is equal to 27. You can introduce the cube root on both sides so that your t is 3, and you're done. So you have solved for t. when the two vectors are perpendicular. To verify your answer, you can simply substitute this one in there and then find the dot product of the two vectors. And then if you're getting a 0, it means your answer is correct. If not, you may want to try again. And then part B2, find the angle between A, which is this, and B, which is that, in degrees. So we have A is, and B, which is 2I plus J. So to find the angle between these two, you can use this formula here. So we have A dot B, the dot product of A and B is equal to the modulus of A multiplied by the modulus of B cos theta, where theta is the angle between the two given vectors. So now, your A is this, this one here, and then dot, your B is 2I plus J, and then the magnitude of A is given by the square root of x squared plus y squared. This is like the Pythagoras theorem. So this is your A, this is your x, this is your y. So you can just say 1 squared plus, where 1 is the coefficient of I there, and then plus 7 squared multiplied by the square root of, to find the magnitude of B, you can just square your x plus 1 and then cos theta. So in most cases we find these two separately, but I don't want to make this video too long. So this times this, remember to multiply vectors, you just multiply the i's by the i's, the j's with the j's. So this times this will be 2, then 7 times this will be 7, because j squared is just a 1, and the reason is simple. J times j is like j squared. J is parallel to j. These are like the y axis. The fact that they are parallel to each other means that the angle between them is either 0 or 180, depending on the direction. So once you substitute your 0 there, you realize that cos 0 is 1. So when you multiply cos 0 by that, you just get a 1. So I times I, or I times I or j times j is just a 1. So you have 1 squared is 1. This is 49. 49 plus this, we have a 50. Then the square root of this is 4 plus 1, we have a 5. And then cos theta, so this plus this is 9, and then you can go ahead and multiply these two, or you can find their square roots and multiply them. So I'll just punch them on my calculator. So the square root of 50 is this, multiplied by the square root of 5, which is this. So we have 15.8114 cos theta. So to improve your accuracy, make sure you write your number correct to 4 decimal places. You only round the final answer off. So to solve for theta, we can divide both sides by 15.8114, this, and that will go. We have cos theta, and then 9 divided by this is 0.5692, and then cos In this, remember to keep your calculator in degree mode so that your theta is 55.3048 degrees, and then you can round your final answer. So when you're dealing with angles in degrees, you round your final answer correct to 1 decimal place and you're done.